Dear learners, in this lecture, we will see the topics standard deviation and variance. If you have a set of data, you can check the precision of the data by using mean, median, and mode. If you want to check on a higher degree for a collection of data that is spreading over a range of values, you can prefer to use standard deviation and variance. Standard deviation it represents when you are dealing with a set of analytical results, it should be accompanied by the indication of precision of the analysis. Various ways of indicating precision are acceptable, and the widely acceptable one is standard deviation, which is represented by small s that you see here. And the formula to calculate standard deviation is square root summation I1 to n xi, which represents the individual value, minus x bar, which represents the mean of the data set, and whole square, whole divided by n minus 1, where xi represents the individual measurement and x bar represents the mean or average, and n represents the number of measurements. A standard deviation can be represented in a graphical terms using a bell-shaped curve, which is also called as a normal distribution curve. If you look at this curve, you can see that the central point along this bell-shaped curve is nothing but the mean or the average. You can choose different set of data. For example, if you are choosing this set of data that is represented by the blue line, only the data that is present in this area, then it represents 68% of the whole amount of data. And that is moving away from the mean by a standard deviation of 1. So what do we understand from this? So 68% of the data are differing from the mean. If you choose 68% of data, they differ from the mean by a standard deviation of 1. Suppose we choose a larger data set, which is represented by the red line, comprising of more number of data, approximately 95% of data, they differ from the mean by a standard deviation of 2. Similarly, if you go on to choose a larger data set comprising of almost 99.7% of data, they differ from the mean with a standard deviation of 3. So if you have numerous amount of data, you can actually choose certain amount of data and you can say how they are moving away from the mean by using standard deviation. In other words, you can simply understand that standard deviation represents how far the set of data are precise or closer to each other. In other words, how they are distant from the mean, both meaning the same. So the formula is again represented here. Standard deviation S equals square root of summation I is equal to 1 to n xi minus x bar whole square whole divided by n minus 1. If you look at the formula of standard deviation, it looks quite difficult to understand. If you solve a problem, it becomes quite easier. Here in this problem, the following set of data of weighings were obtained. You can imagine a student is taking weight of substance and he gets 4 different readings of 4 different samples or substances. And if you want to represent that in milligram. In this problem, it is given in milligram. So you are asked to calculate the standard deviation of the individual values and the standard deviation of the mean, and express these as absolute and relative values. So when you're asked a problem like this, that is, you are asked to calculate the standard deviation. Of course, you need to calculate the mean, because the equation to calculate standard deviation involves mean. So we'll be calculating mean, of course. So you need to write all the individual data given here. So it is 29.8, 30.2, 28.6, and 29.7, all of them under the column xi, and you take the sum of all these values. It is found to be 118.3. You can add with the help of a calculator and see for yourself what is the sum. Then you take the average of these values. So if you want to take the average, you divide the sum of these values by how many number of data sets are there? 4 data sets are there. So the value is 4. So it is 118.3 whole divided by 4. So that brings you the average as 29.6. So when you have the value as 29.6, what we need to do? We need to find out xi minus x bar, where x bar represents the mean. So xi minus x bar, you get different set of values. That is, you need to subtract this value with this value. So here it is 29.8 minus 29.6 is 0.2. If you do the individual subtractions, you get the values. But you may wonder how you got 1 here. It is 28.6 minus 29.6. See, all these values, we only can calculate the magnitude. We don't bother about the plus or minus symbol, because here we want to find out the difference. So the difference is represented here, the xi minus x bar. It is immaterial whether this value is a small one or larger one when compared to all the set of data. So the sum of these value is found to be 1.9. And then you will also be calculating the square of this xi minus x bar. The square of this value, 0.2, is 0.04. Square of 0.6 is 0.36, then 1 and 0.01. You take the sum of all these values. If you take the sum, you can understand better that standard deviation S equals square root of summation I1 to n, which is nothing but this value, 1.41, that is given here in the numerator. So whole divided by n minus 1. N represents the number of data. So we have 4 different set of data. So it is 4 minus 1, which is nothing but 3. So if you solve this equation and take the square root, you get the answer as 0.69. So when you represent this set of data, or the average of this set of data, then you can simply say it is 29.6 plus or minus 0.69 milligram. So that is the standard deviation. So what do we infer from this? See, all these data are differing from each other by a degree of 0.69 milligram. So these values are closer to each other in the range 0.69 milligram. In other words, they differ from the mean by this value, that is 0.69 milligram. So that is the use of standard deviation representing the precision of the value. Similarly, here another problem is given in which the weight of substances are presented and you are asked to calculate the standard deviation. You follow the same procedure. I'm not going to explain it again because the solved steps are presented here. You can solve it yourself and see for yourself what is the standard deviation. If you get the value as 0.20 gram, then your answer is correct. So what is variance? Variance is just the square of standard deviation. So it is S square. When you take the square of standard deviation, naturally the square root is cancelled out. So you only have all the terms that are present inside the square root in the formula of standard deviation. What is a normal distribution curve? A normal distribution curve is presented here. It is a bell-shaped curve. representing the presence of various data, and at the center is nothing but the mean. So this bell-shaped curve usually follows this equation. Y equals 1 by sigma square root of 2 pi exponential whole square x minus mu whole square divided by 2 sigma square, where sigma represents the population mean, x represents the individual measurement value, and mu represents the absolute mean. So where to look for more number of problems? So here I presented some very good books. First book that is given here is the book by Skoog-West, Haller and Crouch. The book name is Fundamentals of Analytical Chemistry, 9th edition. And you can also refer the 7th edition Analytical Chemistry by Gary D. Christian and Dasgupta and Shug. You can also refer Quantitative Analysis by Day and Underwood. All these books contains a lot of solved problems as well as problems. You can exercise problems where you can solve and practice in calculating mean, median, mode, as well as standard deviation and variance. I strongly advise you to solve the problems for yourself in order to get a better understanding of problem solving. Thank you.